In this problem, you're given two functions which relate to each other. So one of them is highlighted in green and the other one is highlighted in blue. Let's look at the one first of all which is highlighted in blue. I'll bring it down here so that we can examine it properly. So the information that you're given is that the value in pounds of a mobile phone T months after it was bought is modeled by this equation over here, where the A and the B are constants. So please keep in mind that this is months for T and the value is in pounds. Now this equation here, you should be able to recognize this as being exponential. Now exponential functions will go either up rapidly or they will go down rapidly. So it's worthwhile knowing what the outcome will be. In this case, we've got a mobile phone which was bought, and we all know that mobile phones or any other article after a certain time will devalue. So in this case, we're going to be looking for the exponential function which is decreasing. So what does it mean for the constant, for instance, b? It means that b will need to be less than 1, but it also needs to be greater than 0. Because exponential functions either increase or decrease very, very rapidly, it's hard to read them properly on a graph. So most of the time it is useful to change that exponential function into a logarithmic function, and just so that it becomes a linear function. And now we want to change our logarithmic function into our exponential function to find out what the constants are in the exponential function. Everything that's written out here is actually shown on the graph. And we're meant to find the initial value of the phone. So we're looking for the V. And we note that initially the value is in here. This is the method that you will use, and this is why you get the first mark in here by showing me this. So to find V, I presume you know how to change the logarithmic function into a power function. And it'll be V is equal to 10 to the power of 3. And because this is a specific question about a mobile phone and the V must be in pounds, we need to write this equation as, or the answer to it, as the value is equal to 1,000 pounds initially, and this is the mark that you'll get. Now in this question, we are told that we need to find an equation for V in terms of T, giving the exact value of A and giving a value of B to 3 significant figures. And this means we need to use this equation here. We need to write it in this form. The only information that's available is the one on the graph. So one thing we can see from the graph that it is a linear function. So we could use this information to write a linear function. One of the ways a linear function can be formed is using this formula y is equal to mx plus c. Now the y value here is obviously our log 10v, and the gradient m will need to be calculated. The x-axis is the time axis, and C is the intersection of the log 10v axis, and that happens to be 3 from the graph. So let's just calculate that m gradient here. M gradient is going to be y step over the x step, and the y step is 2.79, take away 3. And the x step is 10, take away 0. What I'm expecting here for my gradient, I want a negative gradient because we're expecting a decrease. So Is there going to be a negative gradient? Indeed it is. If I use the calculator to find this out, I will get a negative 0.021. And now we can substitute that into our equation. Okay, well that's lovely, but we want this equation to be in the exponential form. V equals AB to the power of t. So we can change this by changing the log form into a power form. This just becomes algebraic working out. Now if you remember, if you have a power which is x plus y, you can split this power up by saying it's 10x times 10 to the power of y. So we'll do the same thing here, and we'll say that that is 10 to the minus 0.021 t, and we're going to multiply this by 10 to the power of 3. And this could be rewritten as 10 to the power of 3, which is 1,000, multiplied by 10 to the minus 0.021 t. So now we can see that A is going to be 1,000. We can still rewrite this and say that's 1,000 times 10 to the minus 0.021 to the power of t. So now all we need to do is to find out what 10 to the minus 0.021 is. And this becomes, from the calculator, 0.953 to the power of t. The calculator, of course, gave us a lot longer number, but we only wanted to 3 significant figures. And we're able to say that A is equal to 1,000 and B is equal to 0.953. And we're able to write our complete equation as 1,000, B is equal to 1,000, multiplied by 0.953 to the power of t. Now for the last section, we're told that exactly 2 years after it was bought, the value of the phone now was £320. So what is the value of this after 2 years? We've got 1,000, we have 0.953, and now this is where you're going to have to be really careful, because 2 years equates with, in terms of months, it's 24 months, because this is supposed to be using months. So we need to put 24 in here. And if we do that, we should get an answer of £315. And so we're asking ourselves, is this a reliable model? Well, our phone was valued at £320, and we are now, our model says that it should be £315. That's basically £5 difference. When you think of £1,000 that was initially, the £5 difference is really not much. So we can actually say that this is a very suitable model. £315 is close to £320. So this is a suitable model. So if you found this useful, then please subscribe to my videos. It'll go a long way to reaching a lot of other people, and also like them as well. And I hope that you have a really nice day.